Okay, today we're going to talk about Pacific halibut and some really cool work that's coming out of the macaw community and others looking at how we can incorporate traditional technologies in managing the species and re-implementing some really cool fisheries technologies around selective harvest. And we'll talk a bit about the halibut biology, but if you don't know, they're a really big flatfish. They can get quite large, and it's not typically something we see when we're out swimming around. They tend to be a rather deep species and highly commercially valuable. Here's a basic life history with females spawning down deep, 1,000 feet or more, releasing eggs, males releasing sperm. Those eggs become fertilized and make their way through the water column, eventually settling out as juveniles in the near shore kind of shallow habitat. They're really interesting. This is true for all flatfish. Through their development, when they're quite small, if you look at this life stage here, they look like like normal fish. They look like a normal left and right-eyed fish. As they metamorphose into a young halibut, they actually flatten and their eyes move to one side of their head. Some flatfish, starry flounders and others, will develop as either right or left-eyed, meaning some of it has to do with latitude, some of it's a bit random. But if you catch one, and what you do is you hold the fish away from you with its bottom jaw on the bottom. And if the eyes are on the right side, it's right-eyed. If the eyes are on the left side, it's left-eyed. So some flounders, some flatfish can be either right or left-eyed. For Pacific halibut, they're all right-eyed, which you can kind of see here. Like this is the belly. Would be the dorsal fin. And that's the lower jaw, and then the eyes are on the right-hand side. So you hold the fish away from you, pretend it's swimming away from you, on its side with the belly on the bottom. And that's how you can tell right from left-eyed fish. Typically, they're quite deep. You do see them in some areas in the shallows during certain times of the year. There are spear fishermen that have taken them in Alaska, usually around salmon runs. And they're encountered on scuba surveys that the aquarium does off Nia Bay in about 50 to 60 feet of water, especially with reef habitat usually. They're a lie-in-wait predator frequently, so they'll lie on a reef and wait for a fish to swim by. And they're typically a gulp predator, so one thing that's different in air than water is in air, if I have something, a jar here, in air, I can reach out, and when I grab it, it doesn't shoot away. But if you can imagine water, if I go like this and squeeze down, this ahead of my hand is creating a propulsion of water. So if I try to do this in water, I go like this, and the jar would move away. So it's different. Like if you think about a snake going around and like grabbing a prey, if you do the same thing in the water, you go around and you try to grab it, there'll be a wave created water motion ahead of the predator that will both let the prey know that it's coming and then also physically move it away. So something like a predatory fish, it's not just lay there, wait for the prey to come, and then go grab it. They also have a gulping motion, and so I'm not sure if it's shown well on this image. A bit here, but their whole gill structure opens up. Their mouth opens up, but when they gape open, it actually does the opposite, sucks water in. So they go for the prey, open their mouth, but more so open their gills, and that stretches out and creates a vacuum for the water to go in. So you often see them on this like rocky reef habitat where they lay in wait for something good to swim by, and yeah, they'll kind of go after it, pounce, but they also open up a lot, and that sucks the prey into their mouth. Let's see. Let's look at the scientific name, which you all know I'm excellent at pronouncing. Hippoglossus stenolepis. Stenolepis. So hippos means horse. Glossa means tongue. So they're horse-tongued. Maybe mean they look like a horse's tongue? Yeah, maybe. I haven't looked at that many horse tongues, to be honest. Steno means narrow, and lepis means scale, so narrow scales, which is true. They have very fine scales. So in Greek, a Pacific halibut is a horse-tongue narrow scale. It's good for, trivia night. You never know. I'm going to jump over to the this website from the International Pacific Halibut Commission, IPHC. Let's see if I can just bring it over live here. I might have to pause and readjust my screen. No, we're kind of fitting in there. So this, we can walk down this and look at a bit about the organism. The 50% maturity age, and remember these numbers because it comes back into the harvest management and how old they are when they're being harvested. It's about 8 years for males and 12 for females. So males mature at a younger age, which makes sense because males just have to produce sperm and females have to produce eggs. And fecundity, which is just a fancy word for how many eggs you have, fecundity and biomass or fecundity and length are tightly associated, which makes sense. If you are a large female halibut, you make more eggs than a smaller female halibut. So there's an advantage to put all of your energy into growth and not reproduction at a younger age. That way you can start to build up that biomass that's needed to produce lots of eggs. They're found off the West Coast all the way, kind of from Upper California, Northern California, all the way through over to Russia and Japan. California has another species called the California halibut that's much smaller. They're related, but it's much, much smaller. Like a big, I think the world record for a spearfished California halibut's like upper 90s, maybe. Where a 90-pound Pacific halibut's not really a big deal. They're pretty common. They can reach a length of 8 feet, which is huge, and up to 500 pounds. It's a big, big, big fish. The larval halibut are pelagic and feed on zooplankton once their yolk sac is absorbed at about 55 days old. So that's quite a while to be living on your yolk sac, which my fisheries professor referred to as the sac lunch from mom. They spawn November to March on the outer continental shelf and slope, so winter, early springtime. Their summer feeding grounds from the continental shelf up to 500 meters water depth. Winter spawning is deeper and further offshore. The oldest age is about 55 years old. So it's kind of interesting. 55 is old. There's definitely older fish. The maturity for a fish species is a bit of an issue, with only 50% of your organisms being mature by 12 years old. Adults eat mostly fish. Juveniles are feed on small-shelled organisms and fish. You'll see they like octopus as well. They pretty much eat almost anything. A 50-pound female will have 500,000 eggs. A 250-pound female will have 4 million eggs. So that's a large difference. And that, just doing the math here quickly, so a 250-pound female is 5 times larger. And 5 times 500,000 would be 2.5 million. So if it was a 1-to-1, meaning for each pound you gain the incremental ratio of eggs, meaning if a 50-pound female produces 500,000 eggs, a 100-pound female would produce 1 million eggs, and you follow it up to 250 pounds, you would expect them to produce 2.5 million eggs, but in fact they produce 4 million eggs. So as they get larger, they have a disproportionately greater number of eggs, meaning 2 or 5 50-pound females produce less eggs than 1 250-pound female. So it's not just a linear biomass regression, it's actually exponential. As early as 2 years old, they will migrate away from shallow nursery areas. You see flatfish up in the shallows, Birch Bay, any eelgrass area. I've never seen a baby halibut. You see a number of rock soles, a number of flatfish, starry flounder, etc. And age can be determined by counting the annual growth annuli, or growth rings, in the otolith, or the ear bone. And so all fish have this ear bone. Actually, I know a couple students have made earrings of them, and I used to keep them. I wish I kept them all. There's something called the stones, but you saw the head, and then you can pull out the otoliths. They put down annual growth increments, same as trees, same as clams, and so we can age them that way, and we can actually reconstruct their migration based on the element ratios within that ear bone. They're opportunistic feeders, and will eat just about anything, really. Makes sense. Pelagic larvae float with the currents. Most of this main predators are marine mammals, sharks, but rarely other fish once they get large enough. Prey consume commonly. They really like octopuses, like a hot bait, if you want a hot tip for going to fish them. So this is a good overview. The Pacific Halibut Commission, we'll talk about, was kind of the arbiters of facts and information about Pacific halibut. So Pacific halibut are commercially fished using ground lines, commonly referred to as a skate. And what this is, it's basically you have a buoy, a line, a large anchor, and then sometimes miles, we call it line, but it's really rope going along the bottom. And you clip hooks to that all the way along. And on each of those hooks, you put a bait, piece of salmon, like I said, octopus, usually salmon. People usually use like pink salmon or whatever's cheap. And you space these out every 20 to 100 feet or more. And you go for as much line as you have. It depends on your permit, etc. And you put another anchor down and a buoy on the other end. And then you leave these out for some period of time, usually not days. In fact, usually on the order of hours, because what happens is it's not that they get off, so they release themselves. Instead of using J hooks, most people use these circle hooks, and when the halibut bites it, the circle hook, like as they wiggle more, it keeps it tight, where the J hook, it's like a traditional fishing hook you would use if you went down to like the pier and had a bobber and worm. You have to apply pressure to keep that hook in the fish. The J hook, the fish gets caught on it and usually doesn't come off. So it's not that you're worried about leaving the line down for a full day and the fish escaping. It's that when they get caught, it's kind of gross, but sea lice, little, they're, let me think, they're copepods, small copepods, attack the fish and will eat it. And I've seen this happen when I've been long lining up in Bella Bella. You left to soak out overnight, and you come back the next day, and you catch the fish, but depending on how long you leave it out and how much sea lice are in the area, within hours the sea lice will eat the entire fish. So we were pulling at fish, and the eyes and the face were eaten off, and the meat was still okay. But you can't sell that in market. Like, the market's not going to want half-eaten halibut that were eaten by sea lice on the bottom of the ocean. So you typically want to leave your set out for a couple hours. I'm going to jump over to this YouTube video looking at some fishing. So this is the macaw boat fishing off Nia Bay. The macaw fishery is pretty typical, and I'm trying to get the size right here. In what they're doing, most of these fisheries, the macaw fishery, everybody on the boat has to be tribal. It's a lot of groups have gone to that. So let's see if I can click it to play. I have to move it over here and hit play. I'm going to talk over it. So what's going on here, I'll get over here in the corner. So this is that long line I was talking about. So they've already picked up the buoy, they picked up the anchor. Now they're just retrieving that line, and you can see that line is really rope. To that, there's these little clips and a leader. It's about 18 inches long, and that's really heavy cord, more than like monofilament fishing line, and then a hook with some bait. And so this guy here is running the hydraulic controls, and basically they just leave it on, and you're just grabbing hooks as fast as they can. Boom, 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 boom. And pay close attention to what he does with each individual one. So once they come up with the halibut, go in the halibut bucket. We got these two guys over here baiting. So they're taking bare hooks, putting bait back on so they can go reset it right away. Cameraman's coming around. This is a better angle here. So we see my man handling the lines here. He's unclipping bare hooks. The bait's gone. He tosses them over there for the other guys to add new bait. You get two folks baiting. You got one guy over here sorting fish. So the guy just off camera sorting fish is unhooking them and piling them up, and then giving the hooks back to the other two guys that are baiting. And then that same guy sorting them out would also toss back any undersized halibut, assuming they get any. So there's a legal threshold, legal size. I think it's 32 inches. So, oh, we missed one here. We'll see some more. We also get a bit of bycatch here. So halibut. That was a small halibut he just unhooked. There's a dogfish that is, we'll call that released. Perhaps bycatch mortality with that. So as you see, it's very busy. Now here we get I believe it's the yellow eye rockfish. Let me pause this real quick. So it's a big old rockfish. You can see its stomach is protruded. When rockfish come up, they get what's called barotrauma, that their swim bladders expand as the pressure is released from the depths of the ocean to the surface, and it causes their stomach to actually invert out of their mouth, and their eyes often to pop out. For hook and line fishers, you're required to have a rockfish descending device. So if you catch a rockfish while you're halibut fishing, you're required to send it back down with one of those, and the idea is that it'll as the fish goes down, pressure will shrink their air bladder, and their stomach will go back on the inside. Unclear how well that works, but let's see what happens to our yellow eye rockfish here. So you can see him separating hooks from halibuts.
I used to hit you on the head.
These are all like mid-size halibut. They've got a pretty consistent size, but not a lot of jumbos. Oh, there goes our rockfish. Likely a victim of what we call bycatch mortality. Okay, we don't want to watch. No, we don't need to watch some dudes. What I did on my certification video. So that's what we're talking about when we're doing ground lines. And so we can look at other videos of them like setting them and that kind of stuff. It's not super exciting, but basically it's the same action in reverse. They put the anchor down as the line's going out, they're clipping hooks on, and they're going over. If you've seen a Perfect Storm, they fish for swordfish, same sort of thing. They're in the back clipping off these, and the one guy gets a hook in his hand, and George Clooney saves him, or whatever happens. I don't recall. So the Pacific Halibut, International Pacific Halibut Commission is, like I mentioned, the arbiters of truth around halibut. They catalog most of the data, and they perform most of the research and set the limits through an international cooperation between U.S. and Canada, and really help regulate the fishery. It's interesting because they're also self-funded, so they fund the International Pacific Halibut Commission by going out and fishing, doing test fishing, and they sell those fish, and that's a major funder of their work, as is like kind of dues that people pay. So the International Pacific Halibut Commission divides the world into a number of chunks. We'll focus on 2A for a lot of this, but note that's a huge area. That's from California all the way up through Sonoma Bay, the end of Washington. So it makes sense that you have, manage halibut in different areas because, geographically they're different. There's distinct populations, that sort of thing. See a closed area here, and then a number of individually managed units. But we'll focus a bit on 2A. So they have a bunch of graphs like this. The first word we need to know, well, these are in a couple different ways, but NUE is number, PUE is per unit effort. So this is number per unit effort. We often talk about it in CPUE, catch per unit effort, which means that we need a way to normalize how many fish are caught. So if every year we catch, let's say, 100,000 fish, every year 100,000 fish, but the first year 100 boats go out, the second year 200 boats go out, the third year 300 boats go out, the fourth year 400 boats go out. While the catch is remaining the same, the catch per unit effort is going down, meaning that there's more effort out there to catch the same number of fish. Now, instead of normalizing it by the number of boats, they normalize it by the length of the skate and how long it's in the water. So every fisherman might have different lengths of sets they make. They might set them for 500 meters, they might set them for 1,000 meters, etc. So they normalize it by, don't quote me, a 200 meter skate, and then divide that again by how much time it's out. So you can think of meters of skate per hour is the sort of catch unit. So here I have halibut per skate. So they define what a normal skate is, and they normalize everything by that. So some folks might use a skate that's twice as long as the average. So that would count as 2 skates. Somebody might use a skate that's half the length, and that would count as half a skate. So they normalize these data. And this is the number of fish. So they don't have the exact weight and length per set, so they use the number of fish. And we've got these different regions. And generally, we've got a little bit different dynamics in different areas, but generally we're seeing this decline from 1995 to current, that generally we're having to use, given the same amount of effort, we're catching less fish. This little number down here is just year over year, comparing 2017 to 2018. Less important, more concerned about the broad trend. And so we tend to see this little uptick and a decline. And this uptick is likely associated with the popularization of halibut and it becoming a bigger market fish. Now here's weight per unit effort. So here they're modeling the weight based on some assumptions for known biomass landed and size distributions of fish caught. So number of fish just tells you how many fish do we kill. But biomass is probably a better measure, right? So you could catch 100 fish this year and 100 fish next year. But if the fish you catch next year all weigh 20 pounds and the fish you caught this year weigh 100 pounds, that's a big difference, right? Like a fish is not a fish. There's talked about that for females. There's a big difference in that. And so here it's a starker contrast if we're looking at the pounds of fish per skate. So here we're peaking up at 180 pounds and now we're down to 75. That's a big difference. If we go back to our prior graph, our catch per unit's 9 and then we're down about 4.5. So maybe it's a similar change, but to me the weight has a more dramatic kind of stretched out effect, as well as it reduces a lot of this noise in region 2, where region 2 didn't look as bad to me in the prior graph, but here we're seeing a big reduction in weight. So we're catching fewer fish and we're catching less weight per set. These are a bit complicated, so I'm going to walk through a few of them. So here we're mostly focused on area 2A. This is the proportion of fish for male and female. You can see a few things here. One, we tend, and this is age. Remember, males become reproductively active after about 8, and females after about 12. And so females are in red. Here, most of the females we are catching are in the range between 10 and 15 years of age. And for males, it's really centered around about 14 years of age. Now, there's a few things going on here. One, it's like, well, we could be potentially catching pre-reproductive females, which is not ideal. The point of fisheries is to let the fish spawn a few times before you catch them. Secondly, we're catching females at a younger age than males. Now, part of that's driven by that males do not achieve as large of a size. If you're looking at big halibut, like 100 plus pounders, 99% of them are female. Big halibuts, always female. Males just don't get as large and they grow a bit slower. So when we're looking at the distribution of big fish, it's almost always female. And so there's this sex-based issue here too, where we're catching a lot of females, which is problematic if we want more halibut. Now this is one that like you look at and your eyes get crossed, but I want to make one point here which I think this graph makes well. So this is proportions at age for females in red and males in blue of the halibut captured in their test fishery. So what this is doing is the bigger the circle, the more common the age class is, and the smaller the circle, the less common the age class is. What I think this graph shows really nicely is if you look at these big circles here, there's a little trend of big circles. So in 1996, we were catching a lot of, say, 7, 8-year-olds. In 97, we're catching a lot of, what I say, 7, 8. These are 8, 9, 10, 11, 11, 12, 13, 14. So basically, you're seeing an age class move through the structure, meaning that every year you don't have this equal number of recruitment into the fishery, meaning you don't have the equal number of fish that survive to legal age. The word recruitment in fisheries doesn't mean baby halibut is happy. It means recruited in a fishery standpoint, meaning legal size to catch. You don't have an even recruitment. Every year is not the same. What you get are pulses. And here in 96, you can see this pulse. We can call those maybe like, 8, 9-year-olds. And then next year they're 10-year-olds and 11, 12, 13, 14. Every year they're getting bigger and bigger. And you can follow them through. So really, we have good recruitment here. Here you can see this kind of big dead spot here. So not a lot of recruitment going back to kind of this area. And then here's a bit of a line, and here's a bit of a line. This would be an example of a really even year. So 2013, pretty even distribution of year classes being fished. Now that matters for fisheries management. If all of our fisheries held up by really 1 or 2 year classes, when those get caught or age out, our fishery is pretty much done. Like, you can have a high, like an upward tick. If we go back and look at our data, we'll see that 96 to 2000 is an upward tick. Really good set. Due to the stochastic nature of the world, every once in a while, a lot of fish spawn and a lot of those babies survive. And then we're catching a whole bunch of fish just due to the stochastic nature of who gets eaten by bigger fish and who doesn't. So we're riding this high of environmental abundance that is, in fact, variable. And the concern, the issue is always, do we define that as normal? Does that become like what we expect is always to catch the crazy amounts that we did in between 96 and 2000? Or was that an environmental anomaly due to a really good reproductive year? So that's like one of the big issues in fisheries management is deciphering what's happening. And here we can see a strong indication of a really tight recruitment, really large recruitment, making it through multiple years of the fishery, supporting that fishery for multiple years. That recruitment drops off. You can see a really even distribution here, kind of an even distribution here, and then kind of a couple of good recruitments going through the system here. So this is sublegal under 32-inch age distributions from the 2018 data. And the age of these fish, males are blue, females are red. So here we can have a male that's, we're focusing on 2A, we can have a male, we have a lot of them. They're 12 years old and they're still not 32 inches. But if you're a female, by the time you're 10, you're legal. So really, when we have legal males, they're much, much older. Females are harvested at a younger age. Bummer, because we want our females to live long enough to spawn. In area 2A, that's a bit difficult. Now this is interesting. This has been going on for quite a while, and this to me is an area of a real big concern. Complex graph. I'll walk through it one by one. Let me figure out what the upper and blowers are. Female, male. Okay, so we'll start with the females up here. So each of these different colored lines is a different age. Here's year. Here's weight. We'll walk through the females up above. In 1995, if you were a 18-year-old female, you weighed 70 pounds. In 2018, if you're an 18-year-old female, you weighed 40 pounds. In 1995, if you're a 17-year-old female, you weighed 52 pounds. In 2018, you weighed 35 pounds. So this is like drawing the age, so you're connecting the dots for weight and age through time. Now, your 18-year-old male in 1995 weighed 26 pounds, so considerably smaller than a female. But in 2018, 16 pounds, like that's a small fish at age 18. So our fish are growing more slowly. The circles are distributions, but they're growing more slowly. That in the late 90s, mid 90s, fish were growing faster. So now we have fish growing more slowly, which is an indication of change in the environment, which is something we need to take into consideration when we're doing fisheries management. How fast fish grow is related to how many of them we can catch. These are similar data based on, this is Bering Sea trawl survey. Ages 15 and greater have been aggregated. So just another way of looking at these data. You can see the similar sort of trend here. This is their age 15 and greater. In the mid 90s, they were large. In 2018, they're half, really, for the big ones. You know, it's a depressed effect for the smaller ones, likely because you know, there's less variation. Like fast fish tend to grow faster, and then that starts to differentiate as you get older. So that's of concern. These are total landings, and these are a bit messy. Get my head out of the way for you. We can look at total landings here. These data go back a lot longer, so this is historical landings that they've tried to reconstruct in just the broad regions, 2, 3, and 4. 2 is like down here, 3 is kind of through Canada, and 4 is Alaska, Bering Sea. Region 2 is a big increase, subsequent big decrease to the 80s, and then kind of back up and around. And so part of this is driven by the Pacific Decadal Oscillation, maybe some INSO events here. So we see some strong evidence of climate forcing, but a strong decline when we zoom out. Think both of historical highs, and then now we're down on this low. Now, what's difficult is to say, okay, what's causing these ups and downs? Because it's an interaction between fisheries oceanography, which is to say the ocean in fact matters for fish, and catch, right? The more fish you kill, the fewer of them there are. The faster they grow, the more biomass there is in the ocean. So you've got these two interacting factors that are often hard to tease apart. Looking at the prior growth data, we've got strong evidence that fish are not growing as fast as they used to, which is of concern if we're still fishing at the same rate. So how we manage fish really matters. We really want to, keep the big reproductive females and ensure that we're leaving enough of the females through the population to sustain it. And then we can add in, those are those commercial landings, we can add in bycatch. There's a big amount of bycatch through here. The pollock fishery is a trawl fishery, would kill a lot of halibut and then discard them as bycatch. Subsistence is this little black line, not very large. Recreational is quite large in area 2A. There's a big wreck fishery. A lot of charter boats, things like that, go out and catch halibut. There's a massive tension between recreational fishermen and commercial, each pointing their fingers about who's at fault. I'm not going to get into that. Commercial discard mortality. So I catch a small halibut and I throw it over the side. A fair amount of them tend to die. So we have to add that back in. So if we're just basing on the commercial numbers, that's not the entirety of the picture. And for sure, there's a lot of recreational fishing. Efforts to reduce bycatch are very valuable because bycatch tends to be smaller fish, sublegal, so you're killing them before they get a chance to even enter the reproductive pool. I'm going to stop here and make a second video talking about the traditional halibut fishing to just kind of break it up. So the first bit's all about how we manage halibut now, and then I'll make a second one about some of the traditional ways of managing fisheries.